Hi, I'm Ahmet Mesait. I'm an EE student in Bilkent University, and today I will talk about my Physics 101 project. So first, let's talk about the theoretical background. Uniform circular motion, due to change in direction of velocity, an acceleration occurs, and this acceleration equals to v squared divided by r. From the Newton's second law, we know that if acceleration exists, then there must be a force that generates this acceleration. And in uniform circular motion, the force is centripetal force and equals to mv squared divided by r. And in uniform circular motion, velocity is equals to 2pr divided by t, which t equals to the period of the motion, and 2pr is the perimeter of the circle. Now, let's talk about the experiment. For the first part of the experiment, I measured the radius of the circle. Then I conducted the experiment and measured the period and the force. Then I added 20 grams to the pack and measured the period and the force again. This is the data I collected. Then I plot the mass versus centripetal force graph, and from the slope of this equation I found the experimental acceleration and compared it with the average acceleration. Then for the second part of the experiment, due to limitations, I conducted my experiment for different radius in a quartic circle. This is the data I collected. In conclusion, in the first part of the experiment, we increased the mass, but the centripetal force decreased as mass increased, which seems like a contradiction because we know that centripetal force equals to mv squared divided by r. However, speed was not constant due to change in period. Since the change in speed is proportional to the square of the speed, centripetal force decreased as mass increased, and we showed that in the graph. And in the second part, we observed the radius of the circular path and its effect to the centripetal force. And the data collected consistently supports the concept that an increase in the radius leads to proportional decrease in centripetal force. And this aligns with the intuitive understanding that a larger radius necessitates a diminished force to maintain circular motion. And in our experiment, due to limitations of the experiment setup, we evaluated the period from just measuring the quarter of the motion and multiplying with 4. This limitation has affected the accuracy of the results. Also, the push given in the beginning was not the same for every push and affected our period measurements. And also air and surface friction was also affected the data collected. And finally, the dynamometer was insufficient to distinguish numbers like 0.05 from 0.08, which occurred in our data. So in conclusion, these results not only confirm established theoretical principles, but also emphasize the importance of considering velocity, radius, and mass when analyzing centripetal force in circular motion.